Each year, over 100 billion aluminum cans are manufactured worldwide. This lightweight yet durable metal is one of the most cherished materials in the world, known for its unique combination of flexibility and strength. Aluminum bends as easily as paper, yet it endures like steel, making it the perfect material for preserving food and beverages. But how exactly are millions of aluminum cans produced each day? In this video, we take a detailed look at how Coca-Cola cans are made. Recycling plays a crucial role in the aluminum industry. Cans arrive from various locations worldwide, tightly compressed into bales that weigh up to 1,000 kilograms each. A single bale can contain as many as 65,000 aluminum cans. Unlike other metals that can be separated using magnets, aluminum requires a different sorting process. The crushed bits of aluminum travel at a speed of 3 meters per second through an optical sorting system. This machine, equipped with advanced infrared sensors, identifies and separates aluminum from other materials. The purified aluminum is then transferred to 2 industrial furnaces that reach extreme temperatures of 730 degrees Celsius. Each furnace can handle up to 100 tons of metal. When aluminum melts, it reacts with oxygen in the air, forming an unwanted layer of aluminum oxide that floats to the surface. This oxide, known as slag, must be manually removed using a giant steel spatula. Beneath the slag, a river of molten aluminum flows into a holding furnace. The next challenge is shaping the liquid aluminum into solid molds. The molten metal is poured into a casting mold, where it forms 3 massive aluminum ingots. These ingots are created by continuously adding layers of hot metal while rapidly cooling each layer with water. This process ensures that the metal solidifies properly and becomes denser over time. After 2 hours, 3 enormous aluminum ingots are ready. Due to the ever-growing global demand for aluminum, these ingots are immediately prepared for transport to a rolling mill. At the rolling mill, the ingots are first heated in another furnace to 525 degrees Celsius. This heating process relaxes the atomic bonds within the metal, reducing internal stress and making it easier to work with. The softened aluminum ingots are then passed back and forth through a series of rollers, gradually reducing their thickness. Once this process is complete, the metal is wound into massive aluminum rolls and sent to Coca-Cola manufacturing plants. At the Coca-Cola packaging facility, the production process is highly automated and extremely efficient. Aluminum sheets are unrolled and fed into a rapid stamping press. This high-speed machine operates at a rate of over 200 strokes per minute, cutting out can ends with each press. Each time the press comes down, it forms 14 can ends simultaneously. The remaining aluminum material from this process is collected and sent back to the aluminum factory for recycling, ensuring minimal waste. Once the can ends are formed, the can bodies are created using a specialized molding machine. A bar pushes the aluminum discs through progressively smaller molds, gradually shaping them into their final cylindrical form. This step requires substantial lubrication to prevent the metal from breaking as it stretches. The lubricant also acts as a coolant, preventing excessive heat buildup during the process. The newly formed cans still have rough edges, which are trimmed and straightened by a deburring machine. They are then transported via a conveyor belt to a specialized washing station. The washing process consists of 6 stages designed to remove grease and other residues. During cleaning, the cans are treated with sulfuric acid and sprayed with ionized air jets to ensure they are spotless. Once cleaned, The cans move on to the decoration phase. A high-speed rotating printing system applies up to 5 different colors, including Coca-Cola's iconic red shade. The printing process is executed with precision to ensure brand consistency. Following decoration, a protective varnish is sprayed onto the inside of each can. This varnish prevents the beverage from coming into direct contact with the aluminum, eliminating any risk of metallic taste and protecting the can from corrosion. The next step is shaping the top portion of the can. A machine creates a 5-centimeter neck, followed by the flanger, which forms a curved rim where the pull tab will attach. Defective cans are identified and immediately recycled. The final stage is the filling process. The cans are transported to the bottling plant, where they enter the filling machine. A high-pressure carbonation system injects gas into the syrup, ensuring that the beverage is perfectly carbonated. To preserve the carbonation, the cans are chilled to 5 degrees Celsius before being filled. The machine's valves can fill 130 cans at once at an impressive rate of 1,700 cans per minute. After filling, a worker ensures the capping machine remains stocked with lids. The caps are securely sealed onto the cans, and a gamma-ray scanner inspects them for proper sealing. Any improperly sealed cans are removed and sent for recycling. Finally, the cans are brought to an ideal storage temperature. Since cold cans could cause condensation, they're sprayed with 35-degree water to bring them up to approximately 27 degrees Celsius. Once dried, the cans are packaged into 6-packs or cardboard 12-packs, ready for distribution. In just a single year, an aluminum can be recycled and repurposed up to 8 times. This continuous cycle ensures a sustainable supply of beverage packaging. If you found this process fascinating, share it with others, and subscribe to our channel for more insights into everyday products.